Hello, everyone. How is it going? Is it good? Great. So, first thing first, I want to have a selfie with you. Yeah, great. Cool. So, who has seen the game yesterday? I did too, and the worst thing about that is that it cannot be unseen, right? Is there anyone from Senegal in here? If yes, then congratulations. I'm also in the awkward position of being in between you guys and the lunch, which means that at the end of this presentation you will be leaving, and I will not know whether you are bored or just hungry. But we have a lot of live coding today. If it breaks, I will be happy to report that this code is up and running at my GitHub account, and I will be sharing links at my Twitter. So, a few words about me. I'm a Spring Developer Advocate at Pivotal. And I'm a pretty weird developer because I prefer talking to the domain experts than new tools or frameworks, which makes me a believer into domain-driven design. Who is here into domain-driven design? There are a lot of people. Cool. I also like to drive my code by test, which makes me a practitioner of test-driven development. And I have a great interest into various architectural designs, mainly microservices nowadays. So I run a blog. I also tweet under Jakub Pilimon. You can find me there. Please drop me a line if you want. And about the last one, I'm very excited because I'm a co-founder of an initiative called DDD by Examples with my friend Michał Michaluk, which is basically a set of projects that aim as a bridge between DDD enthusiasts and Spring users. So welcome you to collaborate with us. Please find us at GitHub if you want. So what we're going to cover today, we are going to cover event-driven architectures. But during first 20 minutes or so, you won't see any event in the code, so please don't be worried. The events will come later on. So first thing we're going to do, we're going to drive our architecture by domain events to have a purely modeled object-oriented programming and test-driven development. To do so, we're going to use a technique called event storming. Who's heard about event storming? Each time I ask this question, the more and more people are raising hands, which makes me very happy. Then we're going to go with event sourcing, and I think that we as a software development industry are past the times of introducing event sourcing, but for those of you who are not familiar with this technique, do not be worried. The definition will come up later on itself. And at the end of this presentation, we're going to go with fully blown event-driven architecture, with Spring Cloud Stream, by the way. So, I promised event storming. It's a nice technique to gather business requirements. It's a nice technique to get to know quickly what our domain is about. It only has two requirements. First of them is gather two groups of people in one room. The first group of people are the people who know which question to ask, so we, the developers. And the other group are the people who know the answers, so the domain experts. The second requirement is to have an unlimited space on a wall and an unlimited number of sticky notes in various colors. That's it. The first question we developers ask is, hey, domain experts, what are the significant facts that can happen in your domain, in your business, actually? And for them, it's pretty easy to answer this question because this is the language they speak on the daily basis. They speak this language in between themselves. So, you know what? We are modeling, we are about to develop a software which issues credit cards. So, billing cycle may end, money can be withdrawn, money can be repaid, limit can be assigned, and so on and so forth. And we write down each of the events on orange sticky notes and put it on the wall. The second question we ask is, what is a trigger for each event to happen? And the trigger may come in one of three forms. The first form being just an explicit command to a system, saying, please do something. Sent from another system or sent by an end user, whatever it is. Like, please withdraw money, please assign limit, please repay. And we put them on blue notes next to the corresponding events. The second form of a cause, of a trigger message, may be just elapsed time. There might be some periodic events like billing cycle closed that don't have like explicit command as a trigger, but just elapsed time is enough for them to be happening. The third cause would be, let's imagine that one event can trigger another event. We don't have it in our example, but for instance, a money withdrawn event can cause an email sent to a client or push notification to a mobile saying you just withdrew this much. Now comes the important stuff. So we ask, hey, is the trigger enough for the event to happen? Or should we check something? Should we check anything in between? Like, for instance, is the withdrawal command enough for the money to be withdrawn? Of course not, you nuts. You don't give away money for free. The system must check whether you have enough money, or maybe you have exceeded the number of maximum withdrawals in one billing cycle, which is 45. So we discover those things called invariants. And we put them on yellow nodes in between the trigger and the event. Like, for instance, the repay command does not have any invariants because we accept any money that the client wants to give us. That's our business model. And now comes some time for analysis. What we can do, what we can take as artifacts from this event storming session. So first of all, it is a ubiquitous language. So the language that the business owners, the domain experts speak, is going to land up in the code. So we discover the ubiquitous language. The second thing is that we can see and spot some relationships between our sticky nodes. Like in here, money repaid event on the orange node may have an impact on a future question asked by the yellow node, is there enough money from a different vertical slice, right? And we discover those relationships like in here. The three slices on the right side have an impact on the one on the left side, which means that this code will be probably used together, will be changed together. Maybe it will be deleted together even, which means it should go together into one class, one module, or one microservice, because we want our code to be highly cohesive. So high cohesion means that the code that changed together should go together into one module class or microservice or so on. So high cohesion is the second thing we get from the event storming session, but that's not it. We also have a common understanding of what are the concepts. For instance, we can spot some people speaking about credit cards, but they have in mind a plastic card with a drawing. So we can separate those sticky notes away from the ones where people think about credit card as a set of withdrawals and repayments, because the first ones are from the marketing department, the second ones are from accounting department, let's say. And we have loosely coupled modules and functionally composed domain. So high cohesion and loose coupling, in my opinion, are the most important principles when it comes to software development. Without them, even the latest and greatest cutting-edge technologies like CIs and CDs pipelines, cloud providers will not help us if we forget about those two principles. So we have the ubiquitous language, we have the high cohesion and loose coupling. Do you know this guy? Who knows this guy? It's Alan Kay. He's the father of object-oriented programming. The creator of the first object-oriented language, I believe, named Smalltalk. He once upon a time said, you know what? I made a mistake naming it object-oriented programming. It should have been named message-oriented programming. It's all about the messages, not about the objects itself. It's all about the messages that we send in between objects. In many object-oriented languages like Java or C# or so, a message sent to an object is represented by a public method on that object, right? So from the event storming session, we get for free the public API of our, let's say, credit card class in this module. So that's the fourth artifact from event storming session, the public API that we are going to copy-paste blindly to our code in a few minutes. And the API will be developed outside in. So we will focus on the behaviors, and then we'll focus on the state. So let's do so. So I'm having a small Spring Boot application and the credit card class. And I'm copy-pasting the trigger messages to our code, like this. Public void assign limit. I'm going with big decimal. I know there are better things to store money in, but trust me, I've seen banks storing money in doubles. So I think for the purpose of demo, big decimal is good enough. Okay, we have three more, right? The second one is withdraw. The third one is repay. And the last one is, hey, the billing cycle just ended. Billing cycle closed. Right. So we have the public API. We can also spot that some of the behaviors, some of the commands were backed by invariants, right? Like here, withdraw and assign limit. So again, we blindly copy-paste this code in here. If limit already assigned, that means we can not acknowledge this command, right? Let's say we are going to throw a new illegal state exception. Again, the same story like with big decimal. Probably a better domain-driven exception would be proper in here. We don't know how to answer this question yet, but it is there. It is there. The ubiquitous language from the domain expert is landing in the code, which is cool. Two more invariants in the withdraw command are, hey, if not enough money to withdraw amount, then please throw new illegal state exception, right? And the last invariant says that if too many withdrawals in cycle, again, please throw me new illegal state exception. So we copy-pasted the invariants from the yellow nodes. We also have the commands from the blue nodes. But that's not all what we can take from the event storming session. Let's go back to our session and take a look. Those vertical slices can be read like this. I can withdraw money when I have money and when I didn't exceed the number of withdrawals. I cannot withdraw when I don't have money. I can assign limit, I cannot reassign limit, I can repay money, and so on and so forth. What are those? These are the test cases ready. From the event storming session, vertically read, we can copy-paste them to our code. To any of our testing frameworks that we like. I personally like Spock framework, so I'm going to copy-paste the test scenarios to our code, like this. We don't know how to implement them yet, but these are the test scenarios from the event storming session. And now, for people who like test-driven development, cool. So you know that there is a red-green refactor loop, but we don't get the luxury of time to refactor, so it's going to be only red-green. And plus, we are going to write all of the tests up front and then all of the implementation. So let's do so. We are driven by behaviors, which means that we can write this code, this test code, together with the domain experts. Cannot reassign limit. What does it mean? It means that given a card with already assigned limit 100, when someone tries to reassign limit to 50, this basically shouldn't be allowed, right? We expect illegal state exception. But when someone just wants 50, it means that the card should say, hey, my available limit is equals to 50, right? We ask the card, hey, what's your available limit? We don't know how to answer that yet, but the question is there. Let's return null for a while. Cool. Can withdraw? It's fairly simple. It means that given a card with, let's say, 100, when someone wants to withdraw 50, it means he or she has still 50 left to go. Cannot withdraw when not enough money. Let's try to withdraw more than we have, 101, and we expect an exception to be thrown in here. Cannot withdraw when too many withdrawals in cycle. Let's copy-paste this one. Given 100 and 45 times withdrawal of, let's say, 1, when someone wants one more, even though he or she still has money, it shouldn't be allowed because of the second invariant, right? Can repay? Let's leave can repay for a while and do the last one. Can withdraw in next cycle means given 100, 45 times withdrawal of 1, and the end of billing cycle. When someone wants one more, basically it should be allowed, right? And the available limit should be equals to hard calculations, 100 minus 45 minus 1, I guess this. And the last one is given a card with a limit 100 and withdrawal of, let's say, 10. When someone wants to repay 5, the card should say, hey, my available limit is equals to, I guess, 95. Yes. Okay, so let's run those tests. I think they will be red. I hope so. And now we are going to do what Alan Kay says is the least important stuff, so the memory of the object. The memory to bug the invariants, to answer the questions, and to answer the invariants. So the state. So what we Java and C# developers are used to do at the very beginning. So let's do that at the end. We can, for instance, store our limit in a private field called limit. Fair enough, right? Amount. Now, it's a good time to answer this question. Hey, was the limit already assigned? Which is fairly simple right now, if limit is not equals to null. The second command was withdraw. I think we could store in a different limit how much we have already used. Let's do so. Used limit equals amount. Let's introduce that field. It should be 0 at the very beginning, right? It should not be amount. It should be accumulative. Use limit plus the amount to be withdrawn. Which means we can answer this question, not enough money to withdraw. We have this method available limit. Available limit comparing to amount that we are going to withdraw should be lower than 0, which means we don't have money to withdraw. Fair enough. What does it mean, available limit in terms? It means the initial limit subtracting the used limit. What is a repayment? Repayment is used limit equals to used limit subtract amount to be repaid. And we are good to go. Only one thing left to do. Something with this, too many withdrawals in cycle. So too many withdrawals in cycle, how to do that? How to answer this question? We could, for instance, store a private list of withdrawal in here. Withdrawals. Withdrawal. Let's name it withdrawals. And it's going to be an array list, right? Cool. As soon as we are accepting the withdraw command, we can add a new withdrawal to our list. Withdrawals, add new withdrawal. Nice. And in here, beginning cycle end, let's leave it for a while. But here, too many withdrawals in cycles, it's pretty simple right now. Is the size bigger or equals to 45? And here what? Beginning cycle close. I think we could, for instance, I don't know, clear the list of withdrawals. Let's see whether the tests are passing. I think they will be green. Fingers crossed. They are green. Cool. But let's stop for a while and think what we have just done with the withdrawal list. So, those of you familiar with ORM know that probably the withdrawal will be backed by a lazy collection, right? Which means that each time, or the first time, our code will assess this list, the ORM will go to the database, fetch all of the withdrawals, and serialize them to withdrawal objects and put them in the list. Which means that we'll do that only to add the new withdrawal at the very end of our list. That's fair enough. It works. We're going to do the same in here, just to call size, so to count from the database. They are only at most 45 withdrawals, which is okay, but let's imagine the requirement changes to 1 million of withdrawals. So we are going to fetch 1 million just to call size on the list. And here what? We are erasing a history, we are erasing something from the database. It's not good enough. That's how accidental complexity gets introduced in our model. Because for a while we stopped thinking about test-driven development, about minimalistic design just to back our invariants from event storming session, and we started thinking how we love to think about models. We Java C# programmers. So one-to-one mapping from the data model, from the database, to our object-oriented model. We missed the fact that there is nothing about withdrawals in the invariants. It's only about count of the withdrawals. So let's correct that. It's not a list, it's just counter, right? Which is at the very beginning equals to 0, fair enough. Here we just increment the counter. Here we just check whether it's greater than 45. And here we have to reset the counter to 0. Right? Yeah, I think we can run the test right now and see whether it's green. It's green. So it's an event-driven architecture. We don't have events in place, but we were driven by events from the events from each session to have loosely coupled, highly cohesive code that speaks the ubiquitous language of our domain model, which is also backed by test scenarios. And in the fact, it's the minimalistic design that only satisfies the invariants. Okay, so now would be a time to think how to persist that model. So how to persist that model in our, let's say, database. So first of all, let's notice one fact. We have the blue nodes in the code. We have the yellow nodes in the code, but there is no notion of orange nodes, the domain events, in our code. So let's fix that in the first place. Let's notice some fact. All of our public behaviors of our model come in the same structure. It's like this. It's a command, a message sent to our object, right? Some of them are backed by invariants. If the invariant says, OK, I cannot accept this command, we are sending an ACK to our client. But from this moment on, we cannot deny acknowledging this command. This command effectively becomes an event in here. This is the place where we change the command to an event, which means that all of the code that is going to be after the invariant is a state change which represents a domain event. That means we can extract it to a method and put the name from the orange node. Limit assigned. This is the way to find our domain events and put them in the code from the sticky nodes. But that's not enough. We want to see like an object, limit assigned, event, not only a method. We want to see what does the event carry, what is its content. So basically, we have it for free because all of the content, all of the parameters that are extracted by our IDE in this method is going to be a content of our event. In this case, just one, plus two universal things. The ID of the object, which is throwing the event, so credit card in this place, and a timestamp, because we want to know when an exact event took place, right? So let's add ID to our card via constructor. I think we'll have to fix our test in here. Yes? Nice. And we can introduce a method parameter object instead of a bunch of objects in here. Let's do so. I will name it limit assigned, of course, and it takes amount, ID of the credit card, and timestamp. So ID, amount, and basically it's happening now, right? What we are left to do, we should make it compile, and that's it. And now we have to repeat this exercise with all of our behaviors. So we are extracting to card withdrawn, right? And here it's going to be new card withdrawn. ID, amount, now. Let's make it compile. Change to event, get amount. Nice. And two last ones are in here. Card repaid, new card repaid. ID, amount, now. And here we change it to event. And the last one is about billing cycle, which may be closed. We extract this one to a method named cycle closed, and put new cycle close in here. This one only takes ID and a timestamp. Yes, and to be symmetric, just rename it to event. So let's check whether our tests are passing, by the way. We didn't change anything from the contract of our code. It should be an implementation detail. Yeah, they are green, cool. So we have the events, but they will be garbage collected in no time, right? So we want them to be somewhere, maybe in our database, because we want to get the state of our credit card later on. So how to persist our credit card? The first idea would be just to add entity in here. It will work, right? We'll have like credit card table in our database with 4 columns or so. It will work. So we will be having the same model in the data model as in our domain model, which is okay because it was driven from this side, from the domain side to the data side, not the other way around. But we can do something different. Let's try to choose different data model to store and retrieve state of our credit card. So we are going to store only those things, only the events. So each credit card which will get its own stream of events so that we can then reconstruct state from those lists of events. This is what event sourcing is about, and you will see that in the code, I guess in 10 minutes. So to store and retrieve state, we use a pattern called repository, right? So I have this class. Is the font good enough for the people in the back seats? Great. More. Now? Cool. So we have a credit card repository which saves and loads a card. It has two responsibilities, right? We also have some tests for this. So for given random credit card, when we assign a limit, 100, when we withdraw 10, we save the credit card, we load the credit card to a different reference. We want this loaded state to be 90, to be in the correct state, right? Let's try it. It will, of course, not work. Yes. And let's try to implement the repo right now. So, as we already said, each of the credit card gets its own stream of events. That means that almost production-ready structure to store those events, hash map will be good, I think. Private final map of ID of card to list of the main event. The main event is just a marker interface that is backing all of the domain events. Let's name it event streams. And initialize with the hash map. I know, not thread safe, but trust me, I've seen banks, so it's going to be good. Event streams. What does it mean to save a credit card? It means, give me all of the events that are not yet stored in our database. Give me all of them. I will append that at the end of your current stream and save the new enhanced stream. And I will mark you, dear credit card, as the one with no pending events. So this is basically how any other ORM will work. There is a concept of dirty checking in ORM, like Hibernate. It does the same. It checks whether something differs at the time of flash differs from the point of loading the state to the persistent context. If it differs, it's going to translate the changes and run SQL statements against our data store. So we're going to do the same. We're going to take a current stream of events, event stream, current stream, right? From event streams, get or default. We want new array list if it's null. So what's the key? The key we can take from the credit card, I guess. Get ID. We don't have this getter, so let's add it quickly. Create getter, nice. And if it's empty, please, if it's null, please give me an empty list. What's the next step? The next step would be add all pending events. Who is responsible to know what are the pending events? Of course, the credit card, because it's the one who's throwing the events in the first place. Get pending events. Let's create this method in here. Create method get pending events. Let's return a list of domain events in here. Return not null, but we'll have to create a pending events collection in here. Field. At the very beginning is going to be a new array list. And each time we are going to throw a new event, or credit card is going to throw a new event, it also should store it in an internal collection of pending events, like here. So we have to copy paste that in here, and do the bidding cycle closed. So here, nice. So now we can answer the question, what are the pending events? Yes. We are now saving our credit card back to the event streams, put under the same key, of course. We put the enhanced stream back to our database, right? And now we mark our credit card, you know what? All of the events were stored. You are not dirty anymore. Equivalent of dirty checking in ORM-based systems. What does it mean to flash events? It, of course, means that credit card doesn't have any more pending events. That was the easy part, how to save the credit card. Now comes the tricky part of how to load the state, based only on the stream of events. So I don't know how to do that yet, so let's create a factory method, static method inside credit card, recreate from. It takes ID, probably will be useful, and of course the stream of events. Again, or default, if it's empty, if it's null, give me an empty list. I want it to be named events, probably better, yeah. So what does it mean to recreate from list of events? It means take the initial state, which is basically a default constructor, get the first event from the event stream. If it's limit assigned, please mutate state accordingly to this event, like in here. Delegate to this method, mutate like this, return mutated state, take the second event, check the type of the event, go to a specific handler, return mutated state, and so on and so forth. Is there anyone who likes functional programming? A lot of people. Cool. This is basically left fold and pattern match. Nothing more. So we are going to do left fold pattern match with our events to get state of credit card. The bad news is that Java 8 doesn't have a built-in support for left fold. So we can play around with reduce, which is something different, or for loop, while loop, or even weirder stuff. Or we can take advantage of a functional library for Java, which is named Vavr. I'm going for the last option because it's the quickest one. So I have to create a list from Vavr. Collection list of all events. Let's static import that. And now I can do a one-liner. Fold left, it takes two parameters, right? It takes initial state, and it takes the B function, which takes a credit card, a domain event, and returns mutated state. So the initial state is credit card, of course. And now, here goes the lambda. Credit card event, how do we mutate based on this event? So let's write a method called handle event. We have to create this method. And the signature of this method tells it all. It's a method on a credit card which takes event as an argument and returns credit card. I think we can simplify that. And here, that was the left fold, and here we do the pattern matching. So it's either for if statement with instance of, or we can again play with Vavr, which will do instance of underneath. But at least that won't be us who will write this instance of code. Cool. So it's going to be api.match event of several cases. The framework requires us to use a dollar in here. Hey, dear credit card, dear event, are you maybe instance of limit assigned? If yes, then please delegate to this method. Bunch of static imports, import and import. Yeah, and it doesn't compile. Why? Because limit assigned is terminating the stream. Basically, we are mutating state, but we should return the mutated state itself, like this. By the way, we should be doing so in all of the event handlers. In here, and in the cycle close event handler. Nice. So now it compiles. We get to copy paste. It's going to be three more cases, right? Nice. If it's card repaid, then please delegate to card repaid. If it's card withdrawn, please delegate to card withdrawn. And the last case is, hey, maybe you are cycle closed. If that's the case, please delegate to this method. Let's run the test and see whether it's green. Fingers crossed, it's green. It is green. That means we just implemented event sourcing in pure Java with left fold and pattern match. And probably we should be talking about why we are doing this. Why do we need that? It's not like a pattern that we are using in every place in our code. It's a pattern that may be useful when we need like natural audit of our code. So basically, having a list of events is a natural audit that we can prove being true, because it's the audit log that we are recreating state from. So there is only one source of truth. The second advantage would be we can travel in time. So we can stop our stream and recreate state from the last Saturday, because that was when we had a bunch of exception logs on our production. So we can recreate state on our local machine and play around. And the first advantage would be there can be different perspective on our event log. Not only a repository, calculate repository can recreate state based on the event log, but we can have different applications that will have different perspective of this event log. Let's say there is an application, a fraud detection mechanism, which looks for two card withdrawn events next to each other that differs just a little when it comes to the timestamp, and one of them is in Krakow, the other one is in San Francisco. So different perspective on the event log. And today, during the great keynote, the second one, we heard about mathematicians trying to apply theories into their romantic lives. So basically, I tried to apply event sourcing theory into my own romantic life. So once upon a time, I used to date this girlfriend, and let's say that our relationship had a very intense event log. And she used to go back to specific events from the event log. And I was like, I understand your projection of our event log, but I have a different projection. I have projection optimized for my needs, and it has to stop. I mean, we have to stop this. You know what? Let's learn about event sourcing, because it has to stop. And we learned about event sourcing, and it stopped. We broke up. Plus, it has some disadvantages as well, because think about when we have to version our events. When an event gets more content. So that's what she was doing as well. She kept adding content to the events. Like, she wasn't even backwards compatible with those events. So it's not only silver bullet event sourcing. It gets also some disadvantages. Versioning, compensating events, different learning curve. Okay, so this is what event sourcing is about. And we have 12 minutes to implement event-driven architecture. So let's assume we have this kind of requirement. Whenever there is a withdrawal in accounting, let's say we have like 4 microservices in our architecture. Accounting is the one we just developed with the credit card. We have 3 more. All of them are Spring Boot applications. And we have to deliver this requirement. So whenever withdrawal is happening, we have to do something in the risk. We have to do something in the payments then. And at the end, we have to do something in the notification microservice. So I see teams trying to implement this kind of scenario like this. They are fairly comfortable with events. They know event-driven architecture, so they already have the card withdraw event. They can throw it out to some kind of a message broker, let's say RabbitMQ or Kafka, it doesn't really matter. And then the risk takes over, does its own stuff, emits a new event, payments takes over, and so on and so forth, up till the very end of the tail. Which will work, right? It works. We can prove it's doable. But let's imagine a scenario when a junior developer comes to our project and is being asked, hey, how does the withdrawal process look like in the code? How does it look like? Basically, he or she will have to pull 4 microservices and try to reverse engineer what's the process. If he or she is done with that, he can, for instance, get a new task. Let's say a new task is change the way we deal with the withdrawal process. Or we are having a new client who wants our platform, but they want completely different way of dealing with withdrawal processes. So basically, we want multi-tenant scenario for different clients. In worst case, we will have to maintain 4 new versions of our microservices, which is insanely unscalable, right? How about this one? How about one guy in the middle, which takes over the whole process? It gets the event card withdrawn and delegates to different people. or different microservices in terms of software development. There's one place to change the code, one place to maintain that, one place to replace if you want multi-tenant architecture. So now we are going to develop this yellow guy, and we are going to use Spring Cloud Stream. Who's heard about Spring Cloud Stream? So basically, it's a neat abstraction for Spring Boot applications that want to talk with each other via messaging infrastructure. The beauty of this tool is that it operates on abstraction of channels. So we don't talk about Kafka or about RabbitMQ in our code. We talk about channels, and the specific channel will be bound to a specific destination based on auto-configuration. So if I had RabbitMQ binder on a class path, it will bind to RabbitMQ exchange. If it's Kafka binder, it's going to be Kafka's topic. So the first microservice, the accounting, will be talking to one output channel. Yes, because it's just emitting events. So let's implement that. By the way, just by accident, on this machine I have RabbitMQ instance running. So what we can do, from the repository, each time we are saving new events to our database, we can also save them, emit them to our RabbitMQ instance, so that someone can subscribe. So to do that, I'm going to use a predefined definition of channels from framework called Spring Cloud Stream, of course. Which source means I'm talking to one output channel, which is a fairly common scenario. That's why it comes with the framework. Let's name it source. Right? Cool. Spring Cloud Stream, yes. So not only we are storing in the database hash map, right? But also we are going to send all of them to our RabbitMQ instance. We're going to take each of the events and send them to RabbitMQ instance. I think we can simplify that. Nice. What does it mean to send? It means take the source, take the output, send a new message. The payload is event, that's it. But you know what? It's good to have some metadata. Just like HTTP headers can inform us about the content type, just in here we can have some headers. So we can have headers and put type just as a metadata to our RabbitMQ instance and all of our consumers, like this. So I think that when we start this application, and we have to somehow create random cards so that we simulate someone is using our credit card application. Let's do random card. So we create each 2 seconds new credit card, assign limit, withdraw, and then we have to save the credit card in a repo. Private final credit card repo. Nice. Yes, so let's run this application. If it's, when we run it, each 2 seconds will emit 2 events to our RabbitMQ instance. Okay? So now we are going to the second application, and we are going to didn't start. Basically, I have binding exception, I guess. Let's change the port quickly, as a quick win, to a different port. Server port, let's say 80. Nice. Let's run this application and try to go to the consumer application, which is basically talking with 3 output channels and 1 input channel, right? So it's talking to 1 input channel and 3 output channels, and we want to develop a scenario whenever there is a withdrawal, we want to emit 3 things to 3 different channels. How to do that? We want this method to be responsible for that. Public void handle domain event. Nice. We mark it as a stream listener. Target means the name of the channel, which is in this terms, in this option is cards. But we also have to notify that we are interested only in not in every event, but in an event that has a specific condition, like this. Let's say the header, to be more specific, a header called type is equals to card withdrawn. Cool. That means that each time there is on a target called cards, there is an event with this metadata. This method should be invoked. What we want here? First of all, we want to test it. So we want to test that each time we get something from the accounting side, we want 3 commands to be emitted. But during test phases, there is a fully blown integration test. We don't want to be dependent on the RabbitMQ instance or Kafka cluster running on our local machine. It's insane, right? We want our test to be independent. Which means we have to use some tools from Spring Cloud testing tools, in particular message collector, which can change the destination of our channel just for the purpose of tests. And instead of sending them to real instance of Rabbit or Kafka, we are going to store in from each channel in a respective locking queue, like this. We initialize these locking queues like this. And hence, we are not dependent on a message broker. So let's write this test. It's going to be when on channels named cards, someone sends a new message. The message has this content, new card withdrawn, some ID, and amount. It also takes some headers in the hash map, type, card withdrawn, of course. Right? Yes. So whenever it happens, we want 3 output channels to be populated with events. So we can do like this. Hey, dear risk channel, give me last event from your side. I want its payload, cast it to string, and check whether it's due risk. And same with 2 others. With payment and with notification. Do pay, and here it's going to be do, let's say, email. Doesn't make much sense, but for the demo, it makes sense. OK, let's see this test failing, and then we are going as a final act to develop this method and see the test becomes green. I hope so, at least. OK, so let's handle the withdrawal in here, which means that we have to notify risk, send new generic message, do risk, and with payments do the same, but just different commands, right? Notification, do pay, do email. I guess it was like this. Let's try to rerun this test. It should be green. It is green. It means we successfully have implemented a process manager using Spring Cloud Stream. Let's check whether the second application is on. It is. So as a final act, we can just run this application and see periodic log statements, let's say. We can just put our event to our log statement. Just let's say it's type. So I'm going to run it. And here we should be able to see each 2 seconds new card withdrawn event, right? It is, like this. The framework also complains that it has nothing to do with limit assign, because we don't register any handler, which is OK in our case. So to recap, we went from business requirements gathering with event storming session, which gave us a tremendous perspective on what is going on in our domain. So first of all, it gives us ubiquitous language. It gives us the high cohesion and loosely coupled modules, so functionally decomposed model. It also gave us a public API of the models that we could develop outside in, driven by test, which, by the way, also were on the sticky notes. Then we tried to persist our object-oriented model, and we basically got to choose whether it's going to be JPA entity or, for instance, event sourcing, which gives us different perspective on the event log, audit log, and the possibility to time traveling with our model. And then we took our events and throw them away to our message broker so that we could implement process manager. Basically, it's a pattern from enterprise integration patterns. One place in the code that maintains the whole process, right? instead of having this tail of events, which basically doesn't scale. If you have any questions, I'm happy to answer them right now. If not, I'm happy to answer them on Twitter, and I'm here for the rest of the day. So enjoy your conference. I hope you had fun, and thank you all for coming.